Okay, here we are, Roberto. Let me introduce a little bit the security maturity evaluation, so the practice that we follow to collect information about how our customers are implementing database security in their organization and the technology that they use. It's almost 3 years that we are running this practice across Europe, and we have interviewed at the moment a little more than 40 customers in many different industrial sectors, including banks, the vast majority of them, insurances, telco and internet providers, oil and gas and energy, utilities, multi-utilities, hospital, healthcare, public sector, and defense in one case in a foreign country. The activity is based on a long 4-hour face-to-face interview with a group of people, including security experts, database administrators, and application developers in a company, in the customer organization, following scripts that are related to 6 knowledge areas. The first and the second are called business context and technical context, and they let us understand what's the context, business and technical context of the company, how do they do business, how do they manage IT in their data center. And then we have 4 knowledge areas that are specifically related to database, and these are the area. Database access control is a set of questions to get information about how the customer authenticates and authorize different class of users. The second area is related to monitoring, blocking, and auditing. So a set of questions to get information about which controls the customer put in place to the SQL before it reached the database, and when it's executed in the database, which are the tracks that it leaves in the logs. The third area is called data protection. Is related to encryption and the usage of real data taken and copied from production to development environment. And the last knowledge area is called secure configuration. Is a set of questions related to the operating system, database server, version, release, patching, software development lifecycle, and so on. Let's see this area one by one. So I have 4 slides, one per area, describing the topic. And for each area, I also have one more slide highlighting the most important mistake or the most common mistakes that we encountered during our interviews. Well, the first area is called database access control. It's a set of questions related to authentication and authorization from 3 different points of view. First, we ask questions about authentication and authorization related to the end user, so people that works in the office, they are business users, they are not working in the IT, and they have access to the database using the application, their application, normally application server in a web application, or in their client in the case of client server application. So it's very common that these kind of users are authenticated in a directory, LDAP or Active Directory, or in a specific application user table that are known by the application itself, and they contain username and password for those users that they have been granted, they must be granted the access to the database. Of course, the application, whenever to make to work, has its own application user ID. So the application itself is a kind of user, is a technical user that have access to the database using its own application user ID. There are also some cases where the end user, so business user working in the offices, they have an account in the database itself. They are authenticated using the database itself. So the arrow that is a dashed arrow that points to the database user table. This practice is quite common, it was common in particular in the client server. Second class of users are related, or questions related to a different group of users, more technical people. Number two, we ask questions about authentication and authorization about database administrator, operating system administrator, developers, second level help desk, and in some cases also we have real users, business users that have access, direct access to the database itself, bypassing and without using the application. So we ask questions about how do you authenticate and which limitation of privilege do you enforce to this kind of users. The third group of people is related to the technical people, system administrator, database administrator, and how do you authenticate and authorize them when they have access to the hosting server, so the machine that hosts the database server, and if they can escalate their privilege to have access to the database and so on. Let's see at least some of the most common mistakes that are listed in this slide. So the first one is a little bit tricky in technical terms. Practically, each application needs an account to have access to the database. It's what's called here application user. But also, when you install a new application, you install using and creating a new user in the database that is called the schema owner. It's a good practice to have two different users. One, the schema owner, that is very powerful user because it can execute data manipulation language, so can read and delete and modify the data, and also data definition languages. So it can execute, this kind of user can always execute modification of the table, modification of the trigger, of the packages and procedures that are stored in the database. And the second is the application user. It should be a good practice, it is a good practice to have a different application user that have limited privilege to the schema. That, for example, it's not common that the application needs to alter the database definition itself. So the application user should be able to do just data manipulation language and not the data definition language. But it's common practice not to have the distinction between the two. Part is a problem due to the past practices and the independent software vendor that in the past they used to program their packages in this way, and part is because of the company do not have defined any policy to make a distinction between the two. The second mistake is the fact that this credential, the application, the credentials that are used by the application to have access to the database are not protected in the application server. So it is possible for somebody with technical skill that have access to the data, to the application server to get in control of the user and password that is used by the application to access to the database. And the first two mistakes combine themselves because it's as I explained before, it's a powerful password, a powerful account. The third mistake is quite common, not always, but it's quite common to find developers that they use application user credential to have access to the production database. It is possible, and it is in some cases accepted in the role definition of their job. So it's normal they have access to the database, the production database, using the application credential. That, as I told before, it's a powerful user, it's a powerful account, and whose credentials are not protected in the application server. So it could be a big or quite big group of people having access to the having access to the database, to the production database in this case. Then there are other mistakes, but let's keep this presentation simple, and let's move to the next knowledge area. As I told you before, the second area is related to mostly related to the control that are executed on the SQL code before it reaches the database, before it is executed. And the second area is related to the log produced, when produced, and if produced by this SQL in the application user table and database table logs and the operating system logs. So the questions are related: do you produce the log? How do you protect the log? How do you collect the log? What do you do with the log? When do you delete the log? And so on. Here we have the most common mistake listed in this slide. The first is related to the controls that are on the SQL before it reaches the database, and very, very seldom we find technology to prevent and to check SQL before it reaches the database. This is a pity because in almost every international report, SQL injection that leverage application defects could be avoided with the technology to put between the application server and database to prevent SQL injection attacks. All the other mistakes are related to the logs. There is a very poor production of log. In the past, logs have been disabled because of the storage that the log occupy and the impact on the performance on the server of the machine that is producing the logs. These two problems in the past made many companies to switch the log off because it was cumbersome to manage the impact on the storage and on the power or the processing power of the machine. And in any case, even when the log is produced, it's never analyzed. It's very seldom analyzed. So in some cases, it is shipped to the CM or to the CERT, to the SOC, to the CERT, and so on. So other tools, organization, and procedures, but very seldom is analyzed. So there is no alerting. There's nobody, no tool, no organization that has the task, the duty to check if in the logs there's something strange in terms of attack patterns and so on. I also want to add a comment here. It's related to the accountability. Since in the previous knowledge area we saw that it's possible to have many different people using the same account, very powerful account, the schema owner used by the application, and not protected in the application server. Because of all these things, even if when the logs is produced, very often it will be written that is a technical account having access to the database. The logs are not protected, they remain in the same machine that is used by the database server. So an attacker, a skilled attacker, can change the database and also alter or delete the logs. Also, the international reports, again, they explain us that security incidents are discovered many months after an incident. And in the case the logs are rotated quite quickly, when you need the information, you will not find it anymore. So the third area is related to data protection. So we ask a lot of questions about the encryption. Does your application encrypt the data? Does encrypt the username and password that is stored in the application table? Is the network between the application server and the database server encrypted? Is the database server encrypted? the network between the database server and the storage is or not encrypted, the storage is encrypted, the network between this machine and the backup and export is encrypted, and the backup and export are encrypted or not. And also we ask questions about the usage of real data, real production data, in non-production copies of the database, typically development environment or user acceptance testing environment or quality environment and so on. In this case, situation is poor. The application do not encrypt. We have evidence of cases where not even the password of the users that are stored in the application table are encrypted. The database is not encrypted, the storage is not encrypted, the network is not encrypting. Here I refer to the encryption of the internal to the company network, not to the network to the in internet. It's just the internal network. There's a perception that this network it will not be attacked and it's not encrypted. And also the backup is not encrypted even when this backup is shipped outside of the company for storage. And so we have seen no, don't encrypt, but yes, unluckily it's the wrong yes, production data is copied to development environments. This is because it's quite difficult and it's more efficient from a programming point of view to use a copy of real data to murder test. If you want to create a test data that are not a copy of the production data, you have many problems. It's like a small project to produce test data that are reliable, represent the good test set. They don't suffer referential integrity problems and so on. In any case, whichever it is the reason, the data are copied to development environment. And these development environment are not protected with security controls that are similar to the production environment. And they are exposed to a larger set of people that are technically skilled with some turnover, outsourcer, and so on. The last area is called secure configuration, and as I told you before, we ask a lot of questions about how you do install operating system and database management server, how do you harden, which policy and procedure you do follow when you do hardening, patching, do you install security patching, when you do that, and how you do that, and so on. And configuration management, a set of questions related to the software development lifecycle. We go a little bit in the practice the company follow to make changes in the application, even when, in particular, when the changes are done on database software components. So you have a new release of the application. How do you bring this new release in production? And so we ask which controls you put in place on the new code, which is the segregation of duty in terms of different people working with different responsibility in the project, in the process. Also change discover if the company has tools to check that an approved baseline that was considered secure because validated with an effort before in terms of software components like packages, procedures, and user with their privileges. Is this approved baseline changing, and it has been changed because of a configuration management process, because of a change in the application, or it is something that is not approved and we don't know why and when it was changed. So any tool and technology that highlight differences in the configuration during the time. The most common mistake here that we find are related to obsolete version of the operating system and database version. They are related to no hardening of the operating system and database, no patching, a poor segregation of duty during the process of changing the software code because of the software maintenance, and no controls on the baseline to discover unapproved changes in the software baseline. Of course, it's difficult to put in place a good patching process, because any patch can have an impact in terms of software service level agreement, because in some cases you have to switch the database server off, and you have an impact on the business. And all the companies today have a 24-hour, 7 days, 365 days service level agreement. So it's always a pain for the business to accept a stop of the database server. And also there is the probability or possibility that a patch that has been applied for whichever reason create a regression problem on the software. So something that was working well before is not working anymore in the same way, with some consequence on the quality of the data produced, on impact on performances and so on. So the patching process is complex, and the company do not have the organization, and they don't want to sustain the cost to put in place a good patching infrastructure, and it's cumbersome. But in any case, nowadays it's not anymore acceptable from a security point of view not to patch a database server, to use a non-supported database version from a vendor, because the vendor in that case it will not even fix the security vulnerability that will be discovered during the time, if any. Well, my conclusion to this long list of most common mistakes is this one. We have a lot of problems that are related to carelessness, or the need to increase the awareness. So the companies and the organization must be more and more aware of the security problems of their software infrastructure and so on. And nowadays it's not anymore acceptable not to consider security as a quality factor, and to be guaranteed as much as possible. We need to follow security best practices and principles. In particular, we need to follow the need to know principle, to limit the privileges that an account has, to enforce segregation of duty, in particular in the software change, in the process of changing software, and accountability. So everybody that is using a system, they must have their own personal account, and even any log and any limitation could be related to a personal account. Because the perimeter is fading out, as I told you at the beginning of this webcast, is not anymore possible to rely just on perimeter defense, and we need security in the depth and security in the architecture. We need to put security in all the cases. It's possible to put security in the middle between the database and the application, in the database as a platform, perceived as a platform, not in every single application, because mistakes and error and attacks can be everywhere. Having said so, less of 50% of the improved control that we recommend to any company when we execute this assessment or maturity evaluation, database security maturity evaluation, as we call it, are related to new products, new option that we, as Oracle, we put in our database. Having said so, we have products And in this slide, I highlight the high-level mapping between the knowledge areas and the products that my colleagues, with the help of Roberto, will explain in the other web seminars. Thank you very much.